Welcome to the Red Hat Summit 2018 demonstration built by Maxim Burgerhaut and Laurent Domp. Today we're going to show you how you can use CloudForm's Satellite 6, Ansible Tower and Insights to deploy a multi-host, multi-tier application fronted by an F5 load balancer. The flow will be that CloudForms is going to provision the Windows hosts and the RHEL nodes. Once the RHEL nodes are up, they're going to automatically register to Satellite. Then they're going to update CloudForms with the service, update the VIP, the web pool, as well as the nodes in F5, install MariaDB on Windows, and then deploy the JBoss application servers and the application itself. Once that's done, we're going to go scan the hosts, run a scan job in Ansible Tower and remediate through Insights. So let's look at the actual architecture on what we're going to use today. So this is Red Hat CloudForms with the self-service portal. We can log in to the self-service portal and we're going to see right away that I have one catalog item which is going to deploy the three JBoss hosts as well as the actual MariaDB database on Windows. We have here the EC2 console. You see that I have no EC2 instances installed named Red Hat Summit 2018. This is Ansible Tower. We have the inventories and Satellite 6 where we can check the registration status of the hosts. We also have the F5 load balancer. As you can see, there is no network map right now, no entries are performed. Let's go ahead and deploy the actual application. We're going to name it Red Hat Summit 18. We're going to choose the instance type and then define the web pool and the VIP, which you want to use for that deployment. Next, we can define the service name so that it's clearly identifiable, and then we can go and order the actual catalog item. Soon we're going to see that the service updates and we can then go and check what our service is doing. As said, everything here is deployed with Ansible inside, so there is no Ruby code at all. We see right away under credentials that this was deployed with the AWS LDO credential for Amazon and then the actual user identity of the LDO Vault. The standard out is clearly visible in the self-service UI, and we see when we deploy with Ansible inside that we get the information about group service and users. We're going to need that afterwards to update the service in CloudForms with the VMs deployed, as well as for the dynamic resource objects. The first step is deploying the Windows machine. We see here that we found the Windows AMI which you want to use, as well as define the security group, and now beginning to deploy the Windows instance. So we can check in the EC2 console if that instance is coming up. We see it does. And if we scroll down, we see that we also have this Windows 2012 server image. So it's a Windows image which we're deploying for the MariaDB database later on. The way and how Ansible builds this is it's going to check via WinRM that the instance can be provisioned. And once done, then the Linux instances are going to go and get provisioned as well. So we can update the console again. We see two instances already came up. One's initializing, but essentially we can go check for the IP addresses and then see if they already registered to Red Hat Satellite. But before we do that, we can also look at the actual user data, because that's what we use to go and register to the correct host group in Satellite as well, and also make sure that Satellite afterwards can connect to the actual EC2 instances. So let's go ahead and check if Red Hat Satellite actually sees the hosts. So What we see now is the original host which we had in Satellite already before the deployment, and the refresh shows now the new hosts in that environment. So we are now in the JBoss EAP host group, and as you can see, we're also applying some Puppet classes with the Insights client, SCAP client, and Java, which we need for the JBoss hosts. Next, we're just going to verify that everything is okay with the deployment, and we see that the third host is getting provisioned now. So once all the nodes are provisioned, we have the Windows node and we have the 3 RHEL nodes, we're then going to go and update the F5 load balancer. Let's verify that everything is okay. We see now that we have 4 instances, the Windows instance and the Linux instances. So 142, 247, and the IP address of 74. And we can go check in Satellite now that all the hosts have checked in and are part of the correct host group. We see here that that's the case again. Registration is very important, that they have the correct channels for JBoss EAP so that they can then build the application server and connect to the Windows MariaDB database. So next we're going to go and add those VMs to the service so that we can track them through the lifecycle. We also know now what the IP addresses are for the JBoss instances, and that means we can add our first dynamic resource object for the F5. So we're going to add the pool, we're going to add the nodes, and we're going to add the VIP to that dynamic resource object. Once that's done, we're actually creating the components on the F5 load balancer. So let's go and verify if all those components were added through Ansible in the F5. We see right away that we now have a VIP, we have a pool, a web pool, and we have the 3 nodes attached to that web pool. The next step in our installation flow is installing MariaDB on Windows. We're also going to add a dynamic resource object named MariaDB in CloudForms as well. Once that database is installed, we're going to kick off the JBoss installation on the 3 nodes and then deploy the application, the jar file, on the hosts. The last step of the install is also run the insights scan so that we get some insights data on the nodes. So let's go check on the provisioned instances. This is the Red Hat Enterprise Linux instance, one of the JBoss instances. We can also check the Windows instance with MariaDB. Now, new in CloudForms 4.6 is the concept of dynamic resource objects. As you can see here, I created 3, an F5 object, a MariaDB object, as well as a JBoss object. Now you can define the entries in those resource objects. So we can go, for example, and check what we have in the F5. As you can see, I added the VIP, I added the 3 nodes as well, and also the endpoint with the big IP server. I also added a connection string in case I need it later, and I also see the 3 JBoss instances which we installed with the actual server address. So I have full application infrastructure tracking during that service lifecycle. So let's go check if we can actually reach that application which we deployed, and we see we can. So this is the JBoss instance. What I want to show you next is what we can do in CloudForms from a security perspective. We also introduced a new feature called Smart State Analysis in AWS. That means that we can go and introspect the actual instances in AWS. So this is the admin UI. As you can see here, I also see my service. I'm going to go ahead and launch the Smart State Analysis on the Linux instance first. And then I'm going to go and launch it on Windows as well. As you can see here, we have no package content right now. This is going to get updated as soon as the Smart State Analysis is going to be done. Now we can also smart state Windows instances, so it's not just Linux, and we're going to get all the information of that Windows VM as well. Now, smart state analysis can be used, of course, for visibility on what you have, so from a package perspective, processes, files, registry keys, but it can also be used to enforce compliance and then kick off basically auto remediation, which you could run out of CloudForms as well. Now in this demo, on purpose, the auto remediation will be done via Ansible Tower and Red Hat Insights. The way on how Smart State works is that it spins up a atomic host or multiple atomic hosts in AWS, which we see here, and then on atomic host there is a image scan container running, which then scans the actual instances. You can also verify in the tasks the scans. We see here all scans now are completed, and that means we now have the data for those instances available. We can now go and verify the content of the host. The first one is the Windows host, and we see now that we have information about the applications. Let's go verify that we see the MariaDB, which we installed, and we do. We can also check the Linux instances. On the Linux instances, you see that we have package information as well. And we can also look into files. We have the option to just see what files are there, or we also have the option, as we can see in this screen, to check contents of the files as well. All that smart state analysis content is available in the self-service URL as well, here for Windows. And we can also check that content on RHEL as well. So if we check here, we see that that information is available too. So next we're going to go and check out the integration between Ansible Tower and Red Hat Insights. This is going to enable us to remediate issues with specific hosts we deployed. So one of the nodes we deployed is the 43 host, and we see we have an Insights button. We can click on that and we see what's wrong with that specific host. Now with the integration of Insights, we have a auto remediation button which is going to generate a playbook for us. We can define the template name, we can add the credentials, define the limit and choose the playbook, and then run that specific playbook against the host to remediate the issues. You could also add a group, for example, or just leave the limit empty and then define that later during runtime. So as you can see, that template now is available and we can run that against the host. We also know that we had some kdump issues when we looked at Insights, and this is now going to get fixed on that host right away. So I showed you now how that integrated portfolio works. Now you can also retire that service as well through Ansible, which is going to remove all the components we just deployed. So let me just walk you through again what we have. So first we're going to go and delete all the generic objects, and then once we've done that, we're then going to go ahead and begin to delete the actual instances. So we can go now and verify if the F5 pool nodes and the VIP actually got deleted. We see that here now there is no VIP pool or nodes available. The next step then is going to be to delete the EC2 instances. We see all of them already were deleted, and the last step is to unregister the hosts from Satellite 6 that we free up the subscriptions. So this step is quite important because you want to make sure that you can use those subscriptions for other hosts if they are not in use anymore. Back in CloudForms, we can also check that the service actually was retired, and we're going to see that if we look at the retirement date in the service. So thank you very much for watching the demo of a multi-tier, multi-host deployment and retirement through the Red Hat Management Suite.